Okay, so it's 14:01. Let's start. What's new in Pester? So before we go into that, let me say thank you to the sponsors, which are Chocolatey, Centino, Patch My PC, and ScriptRunner. I will be your speaker for the next 45 minutes, and my name is Jakub. You might know me because I'm the owner and maintainer of the Pester framework. And I'm also author of the assert module and profiler module. Assert brings a lot of assertions that you can use with Pester, and I think it's a little underused, so I would definitely recommend you to go and check it out. And profiler will help you to find performance problems within your modules, and it's also really nice to use together with your Pester tests. And I will be showing a little demo of it today as well. This is my open source work, but during my day-to-day, I work as a senior software engineer at Microsoft. I didn't go very far from testing because I work on two testing-related products, which are VS Test and MS Test. But unlike others, I don't represent Microsoft here today. All the opinions are my own, for the disclaimer. And so you can find me on Twitter, like @nohvnd. You can also find PS Pester there. If you want to get in touch, just send me a message. My DMs are open, which also means I get added to a lot of groups with some random people who are trying to sell me stuff for some reason. I also have been living here in Prague for like 10 to 15 years. I don't really remember before I recently moved out. So if you need any info, just ask me. I also try to summarize one of the highlights or some of the highlights in the post that I've been posting to PSConfEU main page. As last year, I have some swag on me. And so there will be a raffle at the end of this talk. And what the winner will get is a Pester t-shirt with a design of their choosing. Hopefully we will have the right size. A bottle of local beer, which until recently was chilled, but I don't think it's anymore. And also, please don't drink it here because then we would have to pay corkage fee. But put it in the fridge in your hotel and maybe enjoy it in the evening. And also a small guide to Prague, so you can find some highlights or something that would be interesting for you here in Prague. So I hope everyone was able to scan this. I will mention it one more time before the end of this talk. This should take you to a Google form. There are a few questions. I'm not collecting any info from that. I just basically need your name, but if you answer to the rest of the questions as well, it would be really nice. We're not going to do much hand raising in here, unlike in the State of the Shell. So if you have any opinions, please express them in that form and I will read them in the evening. Pester is a community-driven project, and I want to say thank you to all the new contributors. If you made an issue on the repo, if you asked a question, if you fixed a typo, if you proposed a feature or implemented it, all of those contributions make Pester a better product or a better tool to use for the others in the PowerShell community. So thank you to all of you. And especially thank you to Frode Flatten and Bravo Kernel. Frode has been doing an amazing job in the past year or more on the main Pester repo, and he implemented so many fixes that I have a hard time keeping up with the pull requests. And Bravo Kernel has been doing amazing jobs on our documentation page, which at the start he proposed we use Docusaurus for that page. He implemented it for us. Now he's maintaining the page and constantly making it better. So if we can have a round of applause for those two guys, it would be awesome. Now let's start with output. And so this is not a very recent change, and a lot of those things that I will be talking about seem like small things, but Pester 5 is getting more and more stable and more refined. And so we have colored output in Pester since forever, but now it's also using ANSI escape codes because now almost every host is supporting them, and they enable us to do interesting things like output colors in Azure DevOps output. And so if you don't know, ANSI colors are like escape codes directly in the text, and then it's up to the host to render them with colors or bold text or whatever is supported. If you don't like this, we also kept the previous way of outputting all this stuff in the code, so you can choose it using the option that I will describe below. And because the ANSI escape codes go directly into the output, then sometimes if you reparse the output, it might not be very useful. And so you can also choose to have output with plain text. So we don't put any coloring inside. We just output whatever there is as a text, no coloring at all. To do this, to configure this, one of the ways is that you get an object using new Pester configuration. And then new Pester configuration has some sections on it. And in the output section, you have different properties. And if you set render mode, which by default is auto, to ANSI, it will always output ANSI coding for the colors. If you set it to console color, it will revert back to the old way. We auto detect for you, so that's why the auto is the default. And so you can kind of just rely on this. If I find my mouse. So this is how it looks in Azure DevOps. Just a quick scroll through. This is not it. Those tests are not colored because those are the P tests that we use to Pester itself, to test Pester itself. And then so here you can hopefully see this kind of pinkish output and this red output with colors. And then actual passed green test. This test itself is trying to show that if a discovery fails, then there will be a failure at the end. So that's why we have like the failure at the start and then a test and then a failure at the end. And then something that looks probably more like what you see in your console, the output of Pester with just everything passing and then some summary at the end. So quite a basic change, but I find it very useful when I'm looking at the output and trying to parse out what's going on. The next change that we have is a CI format, and we detect which exact CI provider you are running on, either Azure DevOps or GitHub Actions, but we are of course open to implementation of more. And if you output the text in a specific format, like hash, bracket, error, bracket on Azure DevOps, then it will detect it and it will see, okay, this is an error, and put it in the UI, and then you can just go to the UI and see it. This is actually a screenshot from GitHub Actions, but I don't remember the exact syntax. I think it's like capitalized error and then a semicolon and new line, something like that. Then we have a CI log level, and so it was brought to our attention that if you use this parsing, it will output errors, and sometimes it's not what you want. You don't want this to be failing your test run. And so there's a new option in the output section, which is called CI log level. And this enables you to go from the errors that you see in the screenshot to be rendered as warnings. Small thing, but useful for some. And then in the output, we also now have something that people have been calling for, and that's NUnit free XML format support. And we moved from NUnit 2.5, which by the way is still the default, so we're not making that change yet. I think that will happen in like Pester 6 to make NUnit free the default. And the problem with NUnit 2.5 is that it doesn't have any documentation. We couldn't find it. I think I even talked with the team that came up with it, but it definitely doesn't have as much documentation as NUnit free. And so NUnit free output format has a known and modern schema. It adds data as properties, and we take the test cases and we put them into the properties. I will show that shortly. It's a start, but we can also now distinguish between suits and test failures, and we can distinguish between describe and context in the output. So for example, if you then want to grab the XML and re-render it in HTML or some other kind of format, you can now know which block was which. So let's look at the demo. So here I have my code, and I'm importing Pester, and then I'm grabbing the new Pester configuration. Zoom in. I will try. Yes. And so now if I run just this section of the configuration, it shows me all the all the options within this section. So if you don't know what's available, you can always do this and explore this configuration object kind of interactively. It shows you this blurb of a help and default values and the possible values. So for me, who doesn't remember what's available there and how to configure it, I always use this. Then I can set this to enabled, set the output format to NUnit free, and then I have a little bit of test code, which has 2 test cases, Jakub and Frode, and compares that to Bravo kernel. And those names are never equal, so my tests will fail. And I didn't define that, which is a big mistake. So now I run my tests, and then I can look at the XML. And because this is now so big, it's just a big mumbo jumbo. So here we have properties, and in that we have type. And the type says describe, so you know this was a describe block. If we move down to the test case, we can see that there are properties on that, and we have the name, which we had defined here. And then we have Jakub, which is the data that were associated with this test. And then, of course, the same here for the second test case, which is for name and Frode. Then we can move to should. And so should is our basis function for all the assertion operators that you can either auto yourself or use the ones that are built into Pester. And one of them is should have parameter, and should have parameter is amazing in ensuring that you defined your function parameters the way you want it, instead of writing like this long list of code that's always the same for the function. You can just use this should have operator. And so the new thing here is that you can now check for multiple aliases, and also it doesn't matter at all how you define the parameter format, if it's like in line, if the bracket or the parenthesis is at the same line or not, which is surprisingly difficult to accommodate for some reason. And there are all the other parameters. So let's see a quick demo of how should have parameter works. And so here I have my function, which is called just getUser. It's quite basic. And then I run this test. I will grab that command using get command. I will say the name, which is getUser, and then I provide it to should have parameter. And I say the parameter should be name, it should be mandatory, it should have alias username and n. And so if you look here, it doesn't have the n alias, so this should fail. And of course it does, and it tells me I expected the command getUser to have a parameter name, which is mandatory, and with alias is username and n, but it didn't have an alias n. I mean, this assertion message is amazing. It tells you exactly what should have been there and what is not there. And if you then have more combinations, it just is great at explaining what should be there. So I can fix my test, put the n here, and then rerun it, and my test passes. Yes. Yes, sure. This one?
Okay, so you provide. I just want to see that you provided how you were doing the should that you provided the command object.
Yes, you get it through this. I think there are one more option, but I don't exactly remember how to do that, so let's not go too deep. And then we have should invoke. Should invoke is used to make sure that mock was called a given number of times. And before this in Pester 4, it was called assert mock called, I think, but we wanted to make all of this unified, and so we called it should invoke. And now it finally also got the because parameter. And the because parameter I use the most because it helps you to put the reason why you are doing the actual thing in the message of the assertion. And so it has the effect of when you go back to the code, you will be able to see what you were doing. And then when it fails in your pipeline, you also know like which assertion actually failed and what was the reason, like what were you thinking when you were writing that code. And so switching to should invoke, I have this function which grabs a user through get user internal, and this grabbing of the user is expensive potentially, so I want to put the user object into cache. I don't care if the user object will be outdated. I just want, like, if I call get user twice in a row, it will be fast on the second call. So I'm trying to do that in my code, and I forgot to implement the actual cache insertion. And so I have this test, which has a mock for get user internal, and then I call get user twice, and then I say should invoke get user internal exactly one time, because the user should be retrieved once and stored into the cache. So I'm kind of self-documenting what I'm doing in here. And it of course fails because I called get user internal twice, and I cannot scroll up in this. It embeds the message in here. So then when I go to my CI failure, I can see exactly what was going on. I'll just speak how we are on time. Okay. Should throw. Should throw has one thing that people often forget to do, and that's you have to provide it a script block. Who here? No, I said we won't going to raise hands, so I'm not going to do this. But a lot of our users forget to put the code in the script block, and if you forget to do that, it will fail. And it will fail in a variety of ways, and one of them is like this, which says cannot convert the system collection hash table value of type system collection hash table to type system management automation script block. If you see this and you didn't even have your morning coffee, it doesn't make any sense. If you're trying to figure out why your test is not working at 2 a.m., it doesn't make any sense. So this message needs to be better, and it got better in 5.5. And so where do we have it? In here. So here I did the mistake. I'm calling get user, which I defined just above, and I didn't put get user in the curly braces. So this would be the correct thing. And so should throw cannot control when my code will run. And so get user just runs and outputs the hash table that's there. And so I run it, and it tells me the input is missing or is not a script block. The input to throw and not throw must be enclosed in curly braces. If I see this, I should be able to figure it out. If this still doesn't make sense, let us know and we can make the message even better. Then mock got the ability to mock manifest modules. And if you know what they are and you are using them, then it's now possible. If you don't know, just act like I said nothing, because I don't think this is used a lot. But it's possible now. Then let's move to execution. And so in here, we have one thing that was driving me crazy, and that's you start your test. You are using a set location or CD in your test, and then you stop your test, and your command line is in a different place than where you started. And so I, for example, have like test PS1 script where I want to run my test, or I have invoke Pester, which just says in the current path. And then I end up in some folder, try to rerun the test, and then I have to navigate back. And it's just so annoying. You know, I could use the full path, but I just want to call invoke Pester and be done with this. And so Pester is now remembering the path where you started at the start and puts it in like a try finally, and then at the end it restores it for you. So this is more consistent. We reset the exit code, we reset the path, we reset other things just to make it repeatable for you so you can rerun tests over and over again and get the same results. So here's a demo of that. I'm running a test which creates a new folder. I go into that folder, and then when I end, in previous versions, I would end up in the folder AAA, which I don't want to be. I don't want to be there. And so I run the test, and I'm again in the root in X where I started. Then before all and after all, these were incorrectly accounted as framework duration, which made Pester look kind of slow in some cases. Where do we have that? So here I have a test, and before all is setting up my test, and it's just sleeping in there to take some time. And then I have after all, which is staring down my test, and it's sleeping there. So if I would run this in previous versions of Pester, I would see that the framework time was 2 seconds and a bit. But this is actually user code. So the user provided this. They're doing something. They might be setting up a database or something, and then they might go back to their tests and analyze which of my tests are the slowest, and they are not going to see the result because this won't be accounted in their tests. And so I run this, and I will now correctly see that here in user duration, I spent 2000 milliseconds executing the code. And in framework duration, which is Pester overhead and should always be just like Pester overhead, we spent 24 milliseconds running the Pester code that does all the stuff around. Then something that might make framework authors happy who build on Pester. Sometimes they automate Pester to create a tool such as DBHX, and then they might want to write tests above that tool that will test those tools automating Pester. And so Pester and Pester have always been possible, and I think even like PSConfEU is another example of such module. But there were some limitations, and one of them was that if you set up a test drive, the inner Pester will just tear it down and it will never come back. You will basically you don't lose the content, but you don't know where it is because it's some GUID folder inside of temp. And so now it's fixed and it correctly restores it. Where's my demo? Here is it. And so I have outer Pester, which is invoking a test. And in the test, I'm creating a new file in my test drive. And then I'm starting another instance of Pester inside of this test. And I'm creating file 2. And then I'm just writing out the content of test drive. And then I exit the first Pester. And then if I try this in an old version, I wouldn't see the file because test drive wouldn't be reassigned to the previous path, but now it works just fine. So I can see that the first one, the inner test drive, got this GUID in temp, has file 2, and then the original one has this GUID and has file 1. You can ask me a question and I will remember to repeat it. Yeah, that's interesting. I think, yes. And I didn't remember it. So the question was, if I'm running Pester v4 inside of Pester v5, will this work, right? I think this should work because it's the outer Pester remembering that it should reinstantiate that PS drive. If it was the other way around, it wouldn't work because you would be using an old version of Pester. Yes. So like DBHX, for example, is, again, I'm just so bad at this. What is the point of Pester in Pester was the question. So there are some tools that build on Pester to use it for automation, like DBHX, where they provide like a template or like a list of things that you might want to test against a database instance, but they don't want to themselves write the automation thing underneath that would actually carry out those tests. So DBHX would say, like, this is the configuration a correct, healthy database has, and they express them as Pester tests. And then they give it to a user, and the user just says, I want to test it against this database. But they themselves want to make sure that their tests are correct and that they actually work. And so they would have another automation above that, which happens to be, again, Pester. So they say, I want to test something that itself is doing tests. That's the point. There's a session on that on Wednesday, yes. Okay, let's move on. Performance. I will drink a little bit water. Or vodka, who knows? So if you didn't scan the raffle thing, here's your reminder. Now you have a second chance. And so Profiler, the newest version, was kind of broken and it couldn't profile Pester. Now that's fixed. We had to resynchronize the interfaces, which sounds really fancy. We changed the names of whatever had to be the same. And so if you want to find some slow code in your module, or you just want to see like where could be like a problem in your code, then you can run Profiler over your Pester test and then just filter out everything that's coming out of Pester, and you will see the slow lines in your code mostly. Or you can also use it to find slow code in our module, which I would be talking about in a second. And so here is a demo called Profiler, obviously. And I have some work in the script block, which I will be providing to my Profiler tracer. I'm invoking Pester over this code, which simply just called start slow, and that sleeps for 2 seconds. This is to show that your code can be however deep. You don't have to have it in the main script block, and Profiler will still be able to find it and identify it as long as it's PowerShell code. And so then I run this trace script, which is coming from Profiler. I invoke that work above, and then I'm using the saved trace, and I'm showing top 50 self-duration, which has top 50 lines of code that were slowest by themselves. And I'm then selecting some stuff from that because I have very small screen estate. Let's run it again so we get the right formatting in the table. And so this then shows me that there was something that was taking 96% of the overall execution time, which was 2 seconds. And then we run it once, and it was the start sleep second to code that we had inside of start slow. And so I said executing the Pester code under Profiler is a great way to find slowness in your code, but also in our code. And we saw that when DBHX started moving to Pester 5, and they tried to make it as fast as Pester 4. And they found a regression in our code that was shipped in 5.4.1, so it's still in the latest published version. And that the import module took 4 seconds to import, or actually is taking. I didn't hear any other complaints, so maybe no one else noticed, or maybe if you're just doing this stuff in your CI, you don't really care. But we fixed the problem, and this will be the point of my talk that is on Wednesday, going past Profiler and profiling your PowerShell code using PerFew. Also, Rob and Jess will tell you on Wednesday at 9 a.m. about the roller coaster of upgrading DBHX to Pester v5. Another regression that was found during this work was that we do a mock cleanup on the startup to remove all like the zombie mocks. So if you're running your tests and you press Ctrl+C, it will just stop immediately. And then all the mocks that were in place remain in place. And so then when you try to rerun your code, you would be able to pick up those mocks and it would break your test or skew the results. And so what we need to do is that on the start, we need to look at the internal session state of every single module that you have loaded, find if we inserted any mocks in there and remove them. And what we were doing is that we were just calling a get command inside of every session scope, which in hindsight is kind of stupid from the point of view of performance, because you keep rechecking every single module over and over, either the one that you already cleaned up or that you are going to clean up. And so we replaced this with get child item and the function provider Pester mock, and that makes it much faster. And this also scales with the number of modules that you have. So this is what Rob measured. If you have 8 modules loaded, we had like 20 milliseconds for this, and then we had 2 milliseconds. But if you have 19, for example, if you use DBHX and there are a lot of stuff around, then you went from 314 milliseconds for the import to 5 milliseconds. So small change, but if you re-import the module multiple times in some kind of pipeline, it is visible. And that's exactly how it got found. And then we have code coverage performance. So there are 2 types of code coverage in Pester. One, the old one, is depending on breakpoints. And PowerShell is not very good with breakpoints, because if you have more than 100 of them, then it gets slow. And Pester easily can make few thousands of breakpoints, because it needs to stop at every single point in your code and check, was this run, was this run, was this run, and so on. And so inside of the code, what was happening is that on every, I think it's called sequence point hit, we reached the breakpoints, looped over all of them, and then they were also copied into a new array. I made a change in PowerShell where you use a dictionary, which basically indexes those by file and then by the code point. So when you look in the breakpoint up, you can just check this file, this code point, you get it immediately. And then you also don't copy the breakpoints to new collection every time. And I think this makes the performance increase like tenfold. So in the next version of PowerShell, if you're using code coverage, the old one, which I think most of you are using anyway, you should see like huge speed up inside of code coverage. If not, let me know, because this is just theory. I didn't really test it, but that was why I implemented the change. You can look at the pull request. It's not very complicated. And then the last thing, documentation. So every new feature needs documentation, and we have this Pester dev page, which is maintained by Bravo kernel and Frode and me a little bit. And so, why click that link? The thing is that it needs to be constantly updated. People are saying this is not clear, or this could be done better, or we need for this new feature documentation, and Frode and other people have been writing this documentation and also maintaining the page, so we can have like cool stuff like this. So you read this and then you go to this code, but you don't want to be distracted by the code that you actually need to be able to run this test. So they put it maybe in this like nice block that they had to import there. Or we have a search powered by Algolia. So when I say mock, it will show me everything indexed and so on. We also get great statistics from Algolia. So in the past 3 months, there were like 1,000 users. It's not a huge audience, but I think it's still worth to document your project. The most searched word was should and mock, and then there's like 40 pages of increasingly more rare and weird search terms. So, but nothing obscene. And that's it.